And it's my pleasure to welcome you to the first SGX3 webinar, which is kicked off by the summer interns, which work for 9 weeks at TACC. So let me share my screen for a short intro. So yeah, this is about the summer internship at TACC. And when we talk about SGX3, then it's the successor of SGCI, the Science Gateways Community Institute, and we had these nice 5 areas with diverse expertise on demand with the incubator, the longer-term support engagement with the extended developer support, software and visibility for gateways, the scientific software collaborative, and community engagement and exchange, and the workforce development. And the internship is part of the workforce development. And our message was always, you are not alone. And that stays the way. So you're not alone in the community. So with SGX3, which is the Center of Excellence for Science Gateways, we have also a lot of different services again, and especially also really, again, the workforce development with student internships, with hackathons, with different student programs, with faculty programs. And focus week, sustainability, training, UX consultancy. And if you look at the different services, so SGCI won't go away. We still have also services available, which are client funded, and we have SGX3 funded ones in the Center for Excellence. And if you look here, we are really in the program for the students, summer faculty and student internships. And you see different aspects here with technology evaluation and gap analysis, or focus week, summer coding institutes, and the Rising Stars program. And I will give, after the talks of the interns, then really also an overview of the next couple of deadlines we have. So yeah, the summer internship. So I'm really happy that the students will present their work. There's Dhanny, and he's working on Tapas with the cloud. And then Jackson and Steven, who are working on Scoped, Seismic COmputational Platform for empowering discovery. And I hope I say it the right way, Pritor or Prit. And working with web mobile applications team. And Swati working with the Tapas team on extended the platform to include microservices. And I gave only a short overview because it's my pleasure to introduce them, that they give their talk themselves. And we start then with Dhanny. And I stop sharing.
Sorry, can you enable the screen sharing?
Let me. As I said, my is today really a little bit.
You should be able to now, Dhanny.
Yes.
Oh, for everyone, if you have a question, please raise your hand or put it in the chat. That would be cool.
Hi, my name is Dhanny, and today I'll be presenting my project, which is the machine learning hub that's going to be part of TAPIS. First of all, my name is Dhanny. I'm the software engineering intern part in the ACI team. I'm a master's student at the School of Information in University of Texas at Austin, and my focus is applied machine learning and AI.
Dhanny, it's short. Yeah, maybe we see the next slide fully, but we did see only part of your slides. It looked like.
Okay, yeah, it's sometimes lagging.
Okay.
So I'm part of the ACI team that's led by Joe, and I work with Joe, Anaga, and my POC is Nathan. So the project goal for the Machine Learning Hub is to create a REST API to be a part of TAPIS and integrating the Hugging Face Python SDK that's available publicly. And also specifically for this internship is we are creating the first part of the REST API, which is the models API that would allow non-technical TAPIS users to get information about the available machine learning models and also downloading the models that they desire. And at the same time, we also create a way for TAPIS users to authenticate themselves when they're using the API. So here's my task timeline for the internship. We start with some training, introduction to TAPIS, how it works, and some training in React and TypeScript. And next, I was researching on the Hugging Face API, how to use it, like what API call should I use, and all that good stuff. Next, I start building the Flask API, and we are developing the routes for users to retrieve the models. That is 100 top most downloaded models that's available in Hugging Face, and getting the informations on that. And next step is enabling TAPIS authentications for the users. At the last step, I implemented the model download endpoint that allow users to request models to download to their computers. So here's the system architecture diagram for the API. First, users will access the API through an interface, whether it's CLI or the TAPIS UI. At the moment, it is only the CLI. And then they would hit into the authentication middleware, get authenticated before they can access the APIs. We would have the training API, inference API, and models API. At the moment, we've built the models API. And when a user requests to download the model, we also save a copy of that model into the database. And then if they want to run an inference or training that model, that we will fetch the model itself from the database and send it to the HPC cluster as a job. So for the models API, we use TAPIS Python SDK for authentication, and Hugging Face Hub Python SDK is integrated for us to get the models in terms of information and also the downloading of the models. And we have 5 endpoints for the models API. One is local development authentication. There's one route for that. And there's 3 routes for machine learning models information and a route for machine learning model download. And here's a short demo that I have. I hope it loads.
Testing, I will show you the API usage through Postman. So now we would want to create a post method that has for the authentication endpoint. We also want to make sure that inside the body, we insert our username and password in JSON format. That we can click send here. It's been successfully authenticated, and you can see our GWT token here. To access the list model endpoint, we would want to retrieve that token information. We can do so when you see an environment variable here. You can see that it's already saved in your Postman. So we would want to create a key that's called x-tapis-token and put that token value inside the header before we start our we run our GET request. So the slash model endpoint will give us the top 100 models that is most downloaded in the Hugging Face website. You can see here all the results for each of the models and their respective information. Next, I will show you the list model by author endpoint. So the endpoint would be -p3-mlhub-authors and then author name /model. We would want to do the same and pass the XPathis token in the header. So let's make the GET request. Now we would see how it retrieves all the models that's created by Facebook. You can always change the author here to Google or any authors that you want to look up what they have, like their model. Next, we have the GET model endpoint, and this is meant to retrieve more detailed information about a specific machine learning model that's available. Again, we want to pass the XPathis token in the header before we hit the request, the GET request. You can see here that we retrieved the information, and it has all this different information that you may need when you're running the model. And the most important for this information would be the SHA number, which means that that's the Git repository ID that is associated with their most latest commit, and also the different the information on the different repository content. This is all the files that would be included if you download the full repository for this specific model. Next, we can go to download the model. However, because Postman has limits in terms of the file size that they can get, I will use a VS Code to show you. You can run this curl command, curl localhost 5000 /p3/mlhub/download_model, and then this is the model ID that you want to retrieve. In my case, it's Esperto small that is created by Julian C. And we can type it into our current directory model.bin to see if we've downloaded the model successfully. This might take longer for bigger models, so let's run the command now. So what this command does is retrieve the PyTorch binary file from Hugging Face Hub and download it to your computer. Now we see that the model is downloaded into our computer. It has created a model_cache directory in your computer, and you can see this folder is the models folder. And the way the files are structured, it would say the model name /snapshot, and then this is the SHA repository ID. That way we know that we can match this SHA number with what is the most current repository that we have. And you can see here that it has downloaded the model. Thank you for letting me share this API.
So here's some challenges that I faced when I was implementing the API. First of all, trying to understand how I can integrate the TACC authentication and what functions do I call and what kind of informations do I need to pass and where to pass it. Also, learning about the REST API design, especially more advanced concept about filtering the results, error handling, and the response code, as well as what we get from a response body. And as also lastly is returning the downloaded model to user. How do we want to return the model to the users, and what kind of file do we pass, which part of the report do we want. Some of the learnings that I have from this internship is learning about the best practices in terms of structuring large software projects, version control and code review, testing the API using Postman, and advanced Flask functionality and REST API concepts. Some of the magic moments that I have during the internship is further insight into how backend development works, how the servers and also the different APIs work with each other, as well as being a tourist in my own city. I had the pleasure to be the tour guide for two of my fellow SGX interns, Swati and Prit, and we got to explore Austin a lot. So thank you. So the next steps for this project is first to develop the inference API that allows users to get inference from their desired models, and then implementing the training API to allow further customizations for each users for the model, and also deploying all these APIs in the Tapis Kubernetes cluster, testing it, making sure everything's going all right. Also, we plan to connect the Flask backend to the Tapis UI, React, and TypeScript front end so that we have a portal that users, non-technical users, can use easily. So thank you. If there's any question.
Thank you so much. This is an exciting project. Very good work.
Thank you.
So if anyone has questions, please raise your hand or put it in the chat. And otherwise, we start already with sharing maybe from the next one. And yeah, Jackson and Steven, they talk together about their project. So you might want to start to share your slides.
Yeah, I think Steven has our slides. There we go.
Is it working?
Looks good.
Perfect.
So
Okay, so I can start us out. I think we'll do an introduction first. So do you want to go on the next slide, Steven? So my name is Jackson Thetford. I'm going into my 4th year as a double major in computational engineering and biochemistry at UT. Something I'm really passionate about is computer science and how it mixes with natural sciences, and hence the double major in biochemistry. So yeah, I'll hand it off to Steven now.
Yeah, my name is Steven Oh, and I am a 4th year in computational engineering at the University of Texas at Austin. In this presentation, we will give a brief overview of the project, the primary goals, the areas of growth, and a timeline to summarize what we worked on during the summer internship program.
Yeah. So going into this project, we were given the task of creating a customized Tapis user interface for the Scope project. So for those of y'all that don't know, Tapis is a web-based API framework that helps researchers manage computational workloads and all the complexities that come with advanced computing. So Tapis actually stands for TACC APIs. And then for Scoped is an acronym that stands for the Seismic COmputational Platform for Empowering Discovery. It's an NSF-funded project under the Cyber Infrastructure for Sustained Scientific Innovation program. And so yeah, so to create this Scope Tapis UI, we kind of worked in 2 separate parts. So first, we developed the Scope Tapis UI, and then second, we made the existing Scope project applications accessible through the UI.
Here's a little video of us showing
Yeah,
going to the website and all the components in it.
Mm-hmm. Yeah, so as you can see, we have a login. A lot of this was built on top of the existing Tapis UI, which is kind of just there to help it's like an easy blank slate for starting any portal. So yeah, you can see our systems, our files. This will give users access to any files they want on their system. So as you can, it's a little hard to see, but we have the Stampede and Frontera systems. Those are some job examples. And then here's some of the apps that I will talk later about. Yeah, this is kind of just what the UI looks like, what we have so far. Yeah.
Perfect. There were two main goals for this project. The first was to convert the pre-existing Tapas UI to be scoped friendly. Examples include branding the website with the organization's custom logo and removing unnecessary elements like workflows from the UI.
And then the second goal we had was to build up from the foundation of the Tapas UI we had. And this included adding the scoped apps to the scope tenant, making them accessible through Tapas to the scoped group. We also made two systems that would allow for the group to run jobs and be able to store and retrieve data and files. One of these systems was on TACC Supercomputer Frontera, and the other was on Stampede 2. So we made these systems public to every user under the scope tenant. And then we also added UI elements that would accommodate researchers' workflows, such as a hyperlink for under each job that would allow them easier access to the files associated with that job. And then another form for researchers to be able to make their own execution systems.
In order to tackle these goals, we had to become familiar with new languages like JavaScript and TypeScript, along with libraries like React and NPM, the Node Package Manager. Learning HTML and CSS also helped throughout the development process. In addition, we learned how to use GitHub Pages. First, we published the UI to our own separate pages for development purposes, then published a page under the SciScope domain. After going through the tutorials for JavaScript, TypeScript, and React, we started by working together on smaller tasks. As mentioned in the previous slide, it included changing the UI's header and the name of the tab in the browser. We also got rid of pre-existing elements that the users in Scoped necessarily wouldn't need to use, like workflows. Lastly, we hard-coded scoped.tapas.io as the base path. After working on smaller tasks together to familiarize ourselves with the structure of the UI and Tapas itself, we split off into separate tasks. I took charge of adding new features to the UI that would benefit scoped users, but some of these features also benefited the main Tapas UI project. Oh, a little too ahead. Gonna go back. There were many challenges that I faced while working on the UI. The main challenge was understanding TypeScript itself, as I had never used JavaScript or TypeScript before this internship. Then working with a large project like Tapas UI was another issue. Having to look through a bunch of files to figure out how everything was connected. This allowed me to grow in my ability to work with a larger project, one that I had never seen or contributed to before, while also using a language I've never used before. I also grew in my ability to develop with VS Code and use the browser's developer console for testing. Having used only command windows or terminals to develop in the past, I was able to learn useful tools and shortcuts to develop more efficiently and effectively. The browser's developer console was also very crucial throughout my development process. For example, there were many times when I utilized the console.log method, making sure the variables I was printing the desired outcomes. There were also a few times when I console logged the error that Tapas was returning so that I could catch it later on and perform some sort of action with it. To provide a little background, this past year was actually my first time in computational engineering. I actually wanted to be a mechanical engineer my whole life. However, that didn't mean that I didn't want to be a programmer. I was actually planning on majoring in mechanical engineering with a certificate in computer science. Ultimately, I got into the School of Engineering during my second transfer attempt, having computational engineering as my second choice major. Given that it was my first year in this major, I was nervous at the beginning of this internship as I didn't know what to expect. However, through this internship, I had many magical moments. The first one was that I was certain that this pathway was what I wanted to pursue. This internship opportunity allowed me to feel confident in myself and my own skills. Another magical moment was when my creativity and imagination continued to flow. As I created features for the UI, I continued to come up with new ideas that I thought would help users have a better experience, as well as features that would allow researchers to be efficient. The last magical moment was when everything I had been working on just worked. The feeling of accomplishment is quite special, even if hours and hours of time spent debugging resulted in a single line of code fixing everything. Ultimately, I was able to learn a lot of new things and build a lot of cool features for this project. And there are two main features that I would like to showcase right now. The first feature was actually built due to a challenge that we faced when sharing systems and files with the entire tenant. Even after sharing a system and file path, Tapas required users to add credentials to a system to access the files. While users could achieve this by adding credentials through IDEs like Jupyter Notebook, that would require users to learn and remember proper commands to add credentials to a system. Therefore, I built a React component called add credentials that would display only if there were no credentials of the user for that system. This was what I mentioned previously, where I wanted to catch the error to perform an action, the error being no credentials for the user on the system. This feature used to only work for password authenticated systems, but I had further improved the functionality, and now it is dynamic to the authentication type for the system. As shown in the video, the authentication screen changes as the system's authentication method changes. For example, the password authentication prompts with username and password, while the PKI key prompts with public and private keys. The PKI key authentication even contains the host name and a tutorial link that takes the user to a README file in case the user is unfamiliar with the process. The second feature is the ability to create a system through Tapas UI. Just like the previous feature, users would usually perform this action through other IDEs. However, this allowed users to create systems with ease through Tapas UI. It also allowed and includes all the specific parameters that advanced users might want to mess around with, allowing them to create a system that is perfect for their special use case. As shown in the video, this feature is also dynamic, hiding and showing specific settings depending on the current live parameters. For example, DTN settings only appears when the can execute checkbox is unchecked. So it appears, and then once again, if it is checked, the setting disappears. Lastly, parameters that are arrays are created using array fields, being able to add multiple objects to a parameter. In addition, users are able to delete unwanted objects. The best example is shown in the video with batch logical queues, where the user can add multiple logical queues with different parameters. Here you can see another logical queue being created successfully. I'm just putting in random parameters for everything, and then when you create, it's a success, creates the system, and I hope you can see it, but the first Tapas batch logical queue is shown, and then the test one is shown.
Yeah, so some of the areas of growth for me. So once we had the foundation of the UI completed, I focused more on getting the scoped projects applications up and running on TACC computers through Tapas. One of the biggest challenges I faced while getting these apps running was using Singularity as opposed to Docker as a container runtime, because Docker is not supported on the HPC TACC machines due to security issues. So most of the Scopes Group's apps were made for Docker, and running them with Singularity presented a lot of problems, mainly permission errors that I had to work around. So this just really improved my knowledge of not only Singularity, but writing Docker files, startup scripts, and just working with containers in general. It also gave me a lot of practice in problem solving and testing code. And then working with Steven and other researchers, over several different repositories also improved my knowledge of Git and version control with forks and branches, because just my personal history with school, the longest project I've worked on so far is like a month, and it's maybe me and one other person working with a fork. So this really exposed me to branches, dev branch, making a bunch of different branches for different features. So I'm just really grateful for that opportunity, and that's something I feel that I've grown a lot in. And then lastly, I really feel like I grew in my ability to work outside of my comfort zone with unfamiliar applications. I'll describe these applications further on the next slide, but the Scope project creates applications for advanced computational seismology, which is something I had no prior knowledge of when starting this internship. So going on to the next slide, I'll give you all a quick overview of the applications I was able to get running on Tapas and with Scope Tapas UI. So both of these applications are on the official Scoped GitHub repository, and they're supported by GitHub containers. They're relevant to advanced computational seismological data analysis. So The first one I worked with was called MTUQ, or Moment Tensor Uncertainty Quantification. This app takes in seismic data, then evaluates, describes, and visualizes the data, while also providing uncertainty measurements. Here's some of the sample output from running this container. And that's just from an example script that they have in their repository. So yeah, a lot of seismological data, visuals that I am not very familiar with, but thankfully through trial and error, I was able to get the container up and running through Tapas UI. So now on the next slide. So the second app I worked with was MISPASS, or Massive Parallel Analysis System for Seismologists. It works in a pretty similar way to the MTUQ application, but it holds a different set of resources in the container, and it opens a Jupyter Notebook as a workspace for researchers. So the output of running this through Tapas UI, as you can see on the left side, will give you a link to the Jupyter Notebook. From there, researchers can import data, run data analysis scripts, and retrieve similar output visuals to what you saw on the previous slide. So one of the biggest issues I had while getting these apps to run with Tapas was permissions issues due to Singularity. So for MTUQ, I had to change where the container writes its output and cache files to a directory that the researcher would have permission to write to. When running with Singularity, the user did not have root privileges. So that's why I had to do that. And that was a big issue just because the way that the code was written, it created a file for the output, and Singularity was not letting that file to be created. And then for MISPASS, I had to rewrite the Docker file and create a new startup script that would create a reverse tunnel port to the system's login nodes. This would give the user access to a Jupyter Notebook that was running on Frontier and Stampede. And the startup script I wrote was specific for TACC machines. So if this wanted to be ran on, like, say, one of Hawaii's machines or one of those places, they would have to use a new startup script. But at least now I know how to do it. So hopefully it'll be a lot easier when getting it running for any of those places. So after I was able to get the systems running with Singularity, I made them accessible as Tapas apps by writing and submitting app definitions to Tapas. These are now available on Tapas and usable through the UI. I also submitted app definitions and example job submissions to the Tapas project's application repository on GitHub. And then wrapping up this internship, I was thinking about what to say for this, but I really feel like I had a lot of different magic moments during this process, and it just really gave me a well-rounded experience of what a software engineer does, from the design and development of computer applications to containerizing it and then making it usable and useful to others. I just really enjoyed the exposure to what my future career would look like, and it kind of just reinforced my idea of wanting to be a software engineer. I just got to see what a real-world software engineer does, what it's like. Also, kind of as what Steven said, just working with larger applications like Tapas UI and MISPASS and MTUQ, that just gave me something really unique that I haven't been able to get from school yet. And just honestly, this is the longest project I've ever worked on. So just having this internship as the 9 weeks working with Tapas UI really gave me an opportunity to develop myself professionally. And yeah, I'm excited for the future to work as a software engineer.
Yeah, happy to hear that. Many thanks for, oh, sorry.
Oh, all good, all good. Here's also a timeline to help visualize and summarize our time. During the first 3 weeks, we worked on the same tasks together, completing tutorials and getting familiar with Tapas and Tapas UI. Then we moved on to week 4, where we split off into different tasks, where Jackson took on the challenge of Tapas-ifying applications relevant to Scoped, and I took on the UI side, creating new features. In the end, Jackson was able to Tapas-ify MTUQ and MISPASS, while I was able to create a feature for adding credentials and creating a new system. And then we created a pull request to the main Tapas UI repository as well. And in addition, pushing it all to the SciScope domain. Yeah, just wanted to give a big shout out to our mentors, Nathan, Joe, and Ian as well. I think we couldn't have done most of what we did if it wasn't for y'all's help. But yeah, we can now also be taking questions if there are any.
Thank you very much. Thank you also for a great presentation. So fantastic work. Yeah, the audience, we still will have a couple of minutes at the end also if people want to ask later. So I think with this, I don't
great.
see a hand raised. So I would say we go to the next, to Pritul. It would be great if you share your screen.
Can you see my screen?
Yes. We see it. Yes, now we see it in presentation mode.
There you go.
Take it away.
Hello, everyone. First, I'd like to thank every one of the attendees for joining this seminar today. I'm Prit, and welcome to my summer internship experience presentation. So before I go into all of the tasks that I did, a quick intro about me. I'm a third-year computer science PhD student at the University of Nevada, Reno. Just before starting the internship, I completed my master's degree at the University of Nevada, Reno in computer science. So for my research mainly focuses on the use of artificial intelligence in healthcare. More specifically, I use deep learning and machine learning methods and also virtual reality to detect and predict ocular diseases such as glaucoma, concussion, and some other conditions. So based on my research, if you guess that I don't have much experience with software development, you'd be right. So prior to this internship, I didn't have any professional experience for software development, but I have done some personal projects where I developed some of the softwares. And just before starting my PhD, I worked as a software automation engineer, where I mainly worked with like Python and Selenium and other frameworks to automate and some softwares. So during my internship, I worked with a web and mobile applications team. So Tracy is the manager, and my point of contact here was Sal. He's the software developer and engineering scientist here. Even though I just show only Tracy and Sal, I worked with all other members of the same team. Yeah. So now let's get down to the tasks that I did. So I have done a couple of tasks during my internship here. So for the first task, I was given, it was to fix a bug for a particular application. Well, personally, I thought this was a perfect starting point for me. Because the application was already published, I just was supposed to update some of the codes so that the bug is fixed. So the bug was like if there was like any special characters like ampersand or quotation marks, in that case the app would not work as expected. So I was supposed to fix that bug. Now, the main challenges for this task was the user experience, mainly because I could find a fix for the issue, but it was not user-friendly per se. So that's why I too work with the some of the shell scripting, regex, and Docker and containers to fix the bug. The next task was publish a whole application to the Lone Star 6 system. The application was MATLAB. For those who have worked on MATLAB before, it is an interactive application. So for this one, the main challenge was to create the remote station. And when I first started working on the application, there was some issue with creating remote station on Lone Star 6 system. So yeah, I got to learn about interactive stations, some of the containers during this task. And the next task that I did was for another application, publishing another application for Lone Star 6 system. It was called PSSR. This is from Life Sciences team. And PSSR is the acronym for point scanning super resolution. So what it does is it takes lower resolution inputs and creates a better resolution, high resolution images. So this task was particularly interesting to me, mainly because there was some issues with the compatibility, because the original developer of the software was like so it was like developed like 3 years ago, and there were like new updates and versions from PyTorch and some of the other libraries that has been used here. So the Docker image that was created by the developers was not working. Okay, so we had to change. Well, I had to fix some of the issue there, and when that was not working perfectly, we had to go through the code, like their PyTorch code, and I was trying to fix some of the issues there. But unfortunately, we could not exactly solve all of the errors. Now we are still in talks with the original developer of the application, so hopefully it should be fixed soon. So the next task that I was given was another application. This is from the life sciences team as well. The app is called Napari. So this is like a deep learning framework for viewing 2D and 3D images and do some analysis with the app. So here is a demonstration of how the application works. So as you can see, this is an interactive application as well. And the difference between this application and MATLAB application is that this application is not available as a module in the system. So that's why we need to build this application on top of the interactive shell Docker image. So that's why I had to learn multi-stage Docker building and proper mounting so that it would work perfectly on the Lone Star 6 system. So by the end of this task, I learned about interactive sessions, containers, binary files, and all those good stuff. So for the final task, I was given a task for the portal. This was a bit different from the other tasks because the other task was based on application, but this one was on the portal, the core portal. And the challenge here was that it has a very large code base. And before this internship, I had worked on, well, I had minimal experience with JavaScript and React, but I had to go through and learn React and JavaScript in a higher manner. And finally, the task was done. Here's a short video of job submission. One of my works here for the Napari app. So as you can see, when the job is submitted, as you can from the other slides, if you remember, this is an interactive app, so it creates an interactive session. When you interact, when the session is created, you can interact with the app and create your own images and make some analysis there. So here's the short timeline of what I did here. So for the first week, we were introduced to TAPI's framework and TAPI, and I was introduced to web mobile applications. By the end of week 3, I had a little grasp of web mobile application code base. I learned about bash shell scripting, Dockers, and containers. By the end of week 5, I had published one of the applications. I had learned about interactive sessions, multi-stage Docker builds. In week 6 and 7, I was introduced to the core portal code base, where I had to work with React.js, and for one of the tasks, I had to learn regex. And this is week 9, so we had wrapped up all of my tasks, and I had learned about React.js and JavaScript. For me, it was not a single magic moment. It was like a series of moments that made it magical. So for me, the realization of the work that I have done here has a serious impact, well, indirect and direct impact on the researches done through TACC. Like researchers from different departments and different teams are going to use the applications that we publish every day and make their research further. Here are some of the examples from one of the applications that we published, Neperi, and this is one of the simulations for their segmentation task, I guess. Here are some of the moments that we had during the internship. We had done restaurant hopping. We had done some of the activities like museum visiting. We had also done zip lining, kayaking, and also rock climbing. So yeah, it was great fun. Finally, I'd like to thank members of SGX3, WMA team, and TACC for their constant support. It was a great experience. Thanks for the opportunity, because I got to meet such beautiful minds and work with beautiful minds and also smart people. And I loved my time at Austin here, well, except the hit, but yeah, the vibe is different from the city that I live in. So yeah. So thank you everyone for your attention, and feel free to ask me any questions if you have.
Great presentation. Thank you so much. And I'm also glad here to hear, you know, that you had some fun and that you want to continue with the work. So that sounds good. And the magical moments, as Meta says, are also really nice again. With that, let me see whether there's some questions. A lot of applause for all of you. Not questions yet. So with that, I would say, last but not least, we listen now to Swati and about her work. And Swati, you should be able to share your screen. That looks good.
Is my screen visible?
Yes.
Hello all, good afternoon. And today I'll be presenting my framework that I have been researching on with OSU, and how I'm trying to integrate that with TAPIS, and how that journey started over the summer. So before that, a little bit about me. My name is Manikya Swati Vallabhajoshila. It took me probably a year to even by heart my own surname on how to pronounce it. So I wouldn't mind if people get that wrong. So people call me Swati, so that's like very easy way to address me. And I'm a 5th year PhD student at Computer Science and Engineering Department at The Ohio State University. My advisor, who is also here on this call today, is Dr. Rajiv Ramnath. And my primary area of interest or research, current research, is artificial intelligence and how can we apply that for cyber infrastructures to make allocations much smarter. So moving on, I had a wonderful opportunity to work with Dr. Joe, Anaga, and Nathan this summer, and I've received like tremendous support and guidance while understanding the TAPIS framework, while even writing my own work or prepping for the PERC from them. I've been working with Dr. Joe even before I started with my internship here as part of the Icicle program, and I was like really delighted to work with him over the entire summer. So as part of the internship goal, my primary goal of this internship is to understand the TAPIS framework and how I could break down my own hub, which is the HPC application resource prediction framework, into TAPIS. And along the way, I had like loads of learning curves for understanding containers, how to create containers, how to create APIs using Flask, how to break down my application and put several things into the databases. I'll talk about all of these in the coming slides. So going forward, I'll start with giving a brief overview of HARP, because as part of this internship, my primary goal was to integrate my framework with Tapestry. So I'll introduce the HARP framework, which also received a best paper at PERC 2023. And I have got an opportunity to meet many people from TACC there. And then I'll also move on to how we are proposing to break down HARP and integrating that with Tapestry, which will also continue after the span of this internship as part of Icicle. And I also have a Trello page that has the links to all the papers, the GitHub, and relevant material that I'll share along with my presentation. So before introducing the HARP or the HPC application resource framework, I usually ask this question. And I mostly ask this question to my peers and anybody who actually uses HPC systems. I pull up a job and I pull up their jobs more precisely and Grafana page, and I ask this or that question. So I oftentimes ask them which allocation or which resource utilization looks like your resource. And most of the times people often think right is their allocation and how their job actually executes. They think, oh, they are utilizing all the resources perfectly. But in reality, it's the left that most of their jobs almost look like, especially when they are over allocating the resources. So especially as an example, most of the cases, for suppose if we go for DNN trainings, request for GPUs. But on how the allocation policies at Ohio Supercomputer are, so they request for most of this, they request for the complete node, including the CPUs, which are not utilized. So when I show this and when I say this is how your allocation looks like, the first question they ask is, how do we fine tune our resources so we are not overbuilt? And at the same time, we are not hogging resources for other researchers using the common CIs like OSE or TACC. So when I tell them, you first have to understand several aspects, like you have to understand your own application, whether it's serial, parallel, whether is it efficient on CPU or GPU, and you have to understand the allocation policies or the execution endpoints, like if you're requesting for a Pitzer node versus Owens node, or what kind of execution endpoint node you're requesting. And apart from that, they also have to understand their application's hyperparameter itself. What optimizers were they using, as an example, if it's DNN, or what data sets are they using, or how they are loading their data sets. Were they loading the data sets at the beginning of the application or simultaneously when the compute of the DNNs is happening? So it's quite complex to explain all these concepts to every end user that's probably submitting the job. In reality, how they actually allocate their job is like when they actually know their application, they know their files, they know what endpoints they have. So they start creating their Slurm script. They either take the default recommendation from the OSE web page or the TACC or Frontera web pages, and then they create the default Slurm script. They submit the job, and if the job is executed, they're happy and they stop. But if the job is not executed, that's when they try and go back to analyze their logs and see how much more resources should they actually allocate. But sometimes, even when the job is executed, they rarely even try to analyze the logs, especially only when the cost of their executions is super high or the wait times of the queues are super high. As an example, in the right, you could see these are the two clusters that I initially analyzed. That is, one is Owens and the others is a Pitzer node. And I also saw that like people were more mindful of allocating or requesting for CPUs when they're actually doing a GPU-based job to load the data sets, when they're requesting resources from a more high demand cluster, which has a longer wait time, as opposed to Owens, which is mostly available. So they don't bother fine-tuning the resources. And towards the end, they'll probably have like 7 or 10% of CPU utilization, because most of the CPU cores are sitting idle throughout their lifespan or allocation span. And when we actually saw that if they could simply cut the number of cores that they're requesting by half, or they're actually allocating a smaller queue that actually fits their job, they were able to save up to 40% of the RUs or the cost that they were being billed at OSE. So then we asked ourselves, if we have to train all the users this way, it could be quite complex, but can we have an AI system that could look at the execution or the user behavior and then make these allocations according to the endpoint? Like if it's at TACC, we can define tax policies in like a series of rules. And if it's OSE, can we define it in a series of rules? And can an AI system pick a better allocation given an application and the input data sets? And that's where, that led us to our goal. So can we build a framework that can estimate these resources so that an application could be using the shared cyber infrastructure in a much smarter way, where the resource utilization is not extremely under than what is requested. So as an example, we took one use case, and we saw that instead of asking for one full node at Owens, which has like 28 cores, if you can just ask 10, we are not modifying the performance of the application. It's still the same. It's still taking like that 8 or 10 minutes without modifying the performance of the application, but at the same time, we were able to reduce the cost per job allocation. So with that goal, we wanted to build an AI-driven estimator. So for that, there were several challenges on this way. So if you say you want to build an AI model or a regression or a machine learning model, the first challenge is they're data hungry. So how do we generate that training data set? So if we do not have enough execution of history, how can we create the training data set? So that was the first challenge that we had. And the second one is understanding and capturing the resource specific features. As example, if we are looking at TACC, what all things should we understand before configuring that with our predictor? And if you're looking at OSE, what all things should we understand about the allocation policies, the slurm management scripts, etc. And the third thing is, how do we choose which regression model works for which application? As an example, if we are looking at ENN models, probably most of the features that influence execution time are numeric. So in that case, linear regression or even simple neural network regressors work. But if we are looking at models that have more categorical features like Trimomatic, where it talks about paired end and sequence end, if more categorical features are there, then decision tree regressors work better. So which regression model should we integrate into the framework? And the last thing is what policies. So should we go time-bound allocation or cost-bound allocation? So these were the primary challenges that we were looking at while addressing this framework. And this was the first framework that we have released. And the initial framework prototype was presented in PERC 22. And this year, we have presented the entire analogy behind how to create the AI-based framework and what goes behind creating that AI-based framework in PERC 23. And it received the best overall PERC paper, best paper overall in the conference. So this is the basic workflow. And in the current slide and the next few slides, I'll tell on how the original framework is and how I have actually broken it down so it integrates with TAPIS during this entire internship phase. So initially, when a user gives their application, they give the files and other profiling configurations. And then that's how our framework starts generating the training data set. And once the data set is generated, we create or build models based on the configurations that were available, like based on the hard configurations, like we have some mean square error, different regression models to try, and other configurations of phase 2. And after that, we create all those different predictive models and we stop the profiling phase. After that, when an end user comes and says, hey, I have like Frontera, I have this node on Frontera and this is my application. Can you tell me what's the best wall time that could be needed for this one? In that case, that's when we tell, okay, what could be the best configuration? As an example here, the configuration breakdown in this particular example is showing how do we distribute intra and inter nodes when we were trying to profile a TensorFlow-based DNN model. So here this shows if you have a cost-based constraint, which is the endpoint policy, like some nodes could have like in Frontera, some queues will have like how many days it could be requested for. So based on those limitations, which particular policy can we select based on the time and cost policy? So this is the rough overview of the current framework. But then when we started trying to integrate this with TAPIS, so we have a TAPIS framework, which is another independent framework, and HARP is another independent framework. So now we're trying to integrate our existing framework with TAPIS. So what all potential challenges that we had to come over or look at were the following. So the first one, or the important phase or the more challenging phase, was the generate phase, where we had several questions. So we thought, okay, if we are as a TAPIS or at a tenant or at some endpoint, if we want to generate the user data set, who should we give control to? should we give that as a whole container and ask the user to wrap their code inside our container and run it? Or should we ask the user to give permissions to their application endpoint and take control and execute it as an independent job? But for that, we need new task queues. So should we need new task queues and tappers to execute the generate phase? And if we were doing that, how do we keep the session alive, or how do we keep the user's permissions? Because user's permission will have some expiry, like maybe the web token is active for 6 hours or 8 hours. So how do we keep that active? So those were the different questions that were coming up when we were trying to integrate it as like the first phase, the generate phase. Then after the generate phase, we have some models. For example, if I as an end user was trying to profile a DNN model for vision based classifier. Tomorrow, another person also is using.
Swati, we are 4 minutes already over the time. Can you maybe come to the magic moments?
Okay. So
Thank you.
this is as a quick summarizing. So this is the framework that me, Joe, Nathan, we sat together, and this is almost the final framework that we are coming up together with, which will be released in about a month or so with the Icicle as part of the Icicle project. And I have like tremendous learning as terms of magical moments. I have like huge. So I came into the software development after 7 years. I've done my master's, and there also I've done research in my master's. And I've been doing like more of research and less of software development. But this internship gave me like a complete 2-month window to focus more on the software development. So I got to learn containers, MongoDB, and Flask, which is like the latest technology. Which 7 years ago, it's way different than what it is today. And also I got to think from the framework, or think from the architecture development perspective, which probably I have never done while I was a software engineer before starting my PhD. And then Joe, Anaga, and they were very encouraging when I was like writing my demo paper for the Science Gateways when I submitted that. So I felt really great that they were so supportive when I was even writing papers and not doing pure coding in that particular week. And I'll be working with tappers, and as part of the integration, so it's a continuous integration, I'll be in contact and I'll keep updating people about this. And more importantly, this internship made me realize why I chose computer science and engineering 14 years ago, because my love for coding 14 years ago was revived through this. So I'm really grateful for that I got to focus more on software development as part of this internship. And then PERC was obviously another magical moment that I had during the summer. So I was really grateful for all the help that I received from TACC team. And also I would especially thank Dhanny for taking us across Austin and showing us different places. And I'm like super afraid of heights, but I have done ziplining, and I think I've conquered my fear of water and heights. And also I have revived my passion for development. So I think it's win-win-win situation here.
Fantastic.
I'd like thank everybody again for so much guidance and support.
Thank you so much. And congratulations again, also, of course, to your paper award. And being myself also afraid of heights, I know what it means to deal with that. So we still have time for a couple of questions, or for applauding, or for really thank you to all the speakers. This is fantastic. And so that is, I think this was a fantastic first SGX3 webinar. I love it very much. Wonderful work all. I second Claire there. If we don't have any question at the moment, these presentations were really awesome. So I would make it short then. So please go to our website. So we have on Monday a deadline still for the Gateways conference, for posters, and bring your own portal. So maybe also our interns are also thinking over to submit. I would like to encourage you if you want to do that for the Gateways conference. And so we are looking also for faculty for the faculty hack until September 15th, and also mentors for that. And we have a jumpstart coming up. The applications are also open. And with that, I would then finalize the first SGX3 webinar. Thank you so much, everyone, and thank you for staying with us, and of course the presenters again, and also mentors, and the work at TACC. That is fantastic, and the workforce development program. I hope you all enjoyed this.